Hello and welcome to video number 13, the Foucault's Pendulum for Advanced Experimenters. Today's video is a milestone, I consider, because I've created the most accurate pendulum so far. It includes two universal joints, creating a constant velocity joint over the whole swing train of the pendulum. The pendulum, as a result, I've got a very accurate, very affordable, easily to modify, and it's close to Foucault's original design, except I consider the modern materials I've introduced is the optical fibre cable. As you know, Foucault had to have a special cable wound to have no creep, but we can use optical fibre. He didn't have that advantage, glass fibre. And also, as I mentioned, the two universal joints. I don't believe it interferes with the design, but it creates a more easy to interpret and analyse pendulum with lots of breakout points for experiments. And the rest of the video will be just looking at that new rig that I've for measuring. This was introduced by icansciencethat. He said he's come up with some ideas if you viewers want to see the pendulum and certain how it's measured. Now for me, I can see things that you can't, so I've modified the new rig. We're going to revisit some of those facts and myths that keep cropping up. I'm going to respond to icansciencethat's podcast, a little bit left over from that, and the universal joints, we'll discuss them. That's quite in depth. So quickly I'll go straight to that the new rig, and let's have a look at that. So here we have our new measuring rig assembly. Our camera and laser are mounted on a swivel board, two swivel boards that can be swiveled to give us our angle. The center point of the laser at this point here is 1000 millimeters from the plumb of the pendulum, and we're doing a swing today of 200 millimeters. We've increased our swing to 400 mils now. This is a new launch mechanism assembly where I have a more accurate release mechanism for the cotton, and I can measure the distance more accurately. As you can see right now, the cable is illuminated from the laser, giving us a accurate point. The only modification to the top is a universal joint at the top has been added, replacing the magnetic coupling, and a universal joint down here at the bob. Alright, I think we're ready for a swing. So here's our view looking at the bob through the launch assembly, and I'm about to launch. And our pendulum is now swinging in line with the laser. Although it's blurred, it's just the focal length of the camera, I guess, but it is tracking the laser exactly at this stage. And as I said before, that was a 400 swing. We've just increased the swing distance slightly. I believe that the new universal joints give me more accuracy, and I believe I can go a little bit further with my swing, increasing from 340 to 400. You are unable to see the black line at the far wall at this stage because the laser and the suspension cable are blocking it, but I can focus on that. possibly at this stage, I think you like to see that the tip of the pendulum is actually still in line with that far end laser focusing on the two end of the swivel boards. I think you want to see that at this stage. There's very little wind in the room. You can see by that string hardly moving. Yeah, a shout out to icansciencethat for his suggestions. I think this is a pretty good design. It's something what I had in mind, but I think his idea is a bit better. That laser is still on the tip of the pendulum exactly, and it's within the margin of the remote blurred laser, remembering that is only 1 millimetre at that far end, so we're actually looking at a 0.5 millimetre deviation at this stage in the pendulum. Okay. I think the pendulum is perhaps drifting clockwise. Would that be? The tip seems to be going out, almost outside that far focus at the moment. Going to the left. Not sure. Yet the laser is focusing the suspension cable as the pendulum comes towards me. There. 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 Now, if it was going in a straight line, the laser would be illuminating the suspension cable over that plumb point position, but yet it's illuminating at this near end here towards me, which indicates it's drifting clockwise. Again, very hard to tell at this early stage. The time now is 5 minutes 22 seconds. I'm not too interested in keeping times at this stage, and it's obviously pointless unless it goes anti-clockwise. Here in the southern hemisphere, it's just no use measuring times because we haven't got anything. We have this latitude concept at the moment. Let's just get let's get the pendulum doing the right direction for a start. Alright, to me that is definitely now going outside that far laser line, yes. In fact, the laser is starting to walk around the bob of the pendulum now. Six minutes 42 seconds. Okay, I think the pendulum will die in amplitude before we can get a clear drift left or right, clockwise, anti-clockwise. Maybe not. I'm in the process of designing and manufacturing the mechanical pumping system now, so we'll be able to pump this mechanically for days. But to me, the accuracy of this setup now is well within margins that we can accurately measure drift, if any. Alright, I'm ready to make a call. That is definitely going clockwise. Which it should not be doing in the southern hemisphere. Now, because we have our two universal joints at top and bottom, we can now fine-tune any drifts that may happen. This was just put in randomly. I didn't even look how I located the universal joints. I just put this together. Now we'll discuss that at the end of the video, how they should be aligned. Now, Foucault never used universal joints, as I discussed in previous videos. I believe they were available to him at the time. He was an engineer. I don't know why he didn't use them. But makes sense. You have a object moving through different angles and momentums. You will get some sort of error. The fact that the cable, suspension cable, was doing the job of the two universal joints, I can't make a call on that. It could possibly be good enough, but anyway. Yes, okay, I think we're now 11 minutes in. I think I'll just run this video, but obviously you've got the advantage that you can fast forward. But I'll actually let it run out a bit longer. But to me that's definitely going clockwise. And if we were to pump that for several hours, the pendulum would go clockwise. See if I can get a shot of that remote wall. There's that fine line, that pencil line at the back wall. And the pendulum is oscillating either side of that. So we're talking millimetre accuracy here with this setup. And it's definitely moving clockwise. And again, it would be nice to have this mechanically pumped, where our amplitude would be constant. However, as I am led to believe, and I will keep repeating this, that Foucault did this same experiment within the cellar of his home without any mechanical assist. And I believe he used a pendulum roughly 2 metres, maybe 3 metres in length, before he went to mechanical boost. And he was able to confirm his experiment. So "14 minutes 40 seconds. I think that's enough. The pendulum is amplitude is not showing anything apart from the fact that it did drift clockwise. I don't think it will correct itself, so I think I'll stop the video now for recording, and we'll go on to the next part of our video. Well, I've just started the video again, and I thought I might focus more on that universal joint. At this very low amplitude, it's almost like the universal joint's not necessary, when you consider the angle we're looking at here. But it's quite easy to see the laser travelling around the pendulum. So indicating a clockwise direction. Another thing I should have done, but you have to trust me, take my word for this. If I place a microphone on the joint at on the ceiling, I do not hear any clicking or grinding, which indicates there is no Wilberforcing happening. If you get Wilberforcing, you'll hear a clunk, 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 clunk as the pendulum moves. Okay, I think we're finished now. We'll go back to the whiteboard. So some of the chatter coming from that podcast brought up the old facts and myths concerning the pendulum. Minimum length has to be 12 metres. All I can do is repeat what I heard from evidence that we're pasting together. We can't prove anything, so all we can do is establish facts from experiments. So I have created a 2 metre long pendulum. Now I have vague evidence that Foucault's cellar or his garage that he did his experiments and proved his concept was somewhere between 2 and 3 metres. Now I can't confirm that, so all I can do is make a factual pendulum that I know is a certain length. Now later on, if we find out his garage was higher or his cellar was higher, then fair enough, that's okay. I have to move and readjust things. But right now, he proved, as far as I'm concerned, the concept of the pendulum and the spinning earth within an unpowered pendulum, roughly between 2 and 3 metres in length. So let's just keep experimenting until more evidence comes along. The next one is this pendulum should do a figure 8. Well, okay, I tend to agree with that a little bit. Sort of makes sense as a pendulum does its journey and is a sideways there, and it should come back through the centre. Or an elliptical motion. Look, some of my early inaccurate pendulums did do an elliptical orbit, a cycle, but as I become more accurate, they do that follow a dead straight line. Exactly how I believe Foucault should, how you see the current ones in operation. So the answer to that would be possibly a definite no, but again, it's in red because I'm not 100%. Pendulums work on the Coriolis. This comes up all the time. My gut feeling is no. As we know, Coriolis is a virtual force. It's not an actual physical force. It's mathematically, it's there, but physically, no. And we definitely proved that short lengths of the pendulum in that lathe experiment with that oscillating bar created a frame of reference in a length, 300 millimetres long. So then we get a contradictory argument. Yeah, well, Coriolis effect does actually exist because these Coriolis flow meters, very accurate fluid measuring devices. In fact, if you want to make a Foucault's pendulum, go and buy one of these things. They're off the shelf. All right, so let's keep moving on, trying to keep in character with Foucault. Okay, so a leftover question from that podcast between icansciencethat and myself was, if you want to catch that podcast, it's on his channel, and he was approaching the Foucault's pendulum from a mainstream point of view, mainstream science point of view, and I was approaching it from, I guess, Foucault's point of view in 1851. We didn't know about rockets going to space and proving the Earth spins from space. We didn't know about ring lasers, and we didn't know about gyro compasses and all these other apparatus that we use to determine that the Earth actually spins. So one of the leftover questions, as I said, was to do with the gyro compass, another to be made out of a non-magnetic material. Yes, I did research it. There are ceramic turbines that are available. I believe they are non-semiconductors, so they do not conduct at all, so there's no eddy currents. So you can mount one of those in a gimbal. I'm on that track, but I haven't got there yet. But quite easy to do, mount it on a gimbal, and you've got a gyro, non-magnetic gyro compass. Okay, on the other topics in that podcast, the speed of light rockets, they were fun, but off topic. So I think we should go back to the pendulum. Right now, we'll just move on to those universal joints now. All right, so I guess the advantage of the universal joint is, as I said before, we've got breakout points for our pendulum. If we encounter bias or some abnormality in the movement of the pendulum, we have an access point or a breakout point. The combination for the pendulum, I've sort of discussed this with another colleague, and there's seems to be an ideal combination, whether the swing is this way or this way or this way. So the pin would be this way, and or the upside down, or reverse it, or a combination. So something to think about. I'm not quite sure myself, but just at the moment, using the fact that I can have a breakout point to do analysis. So, all right, I think that's enough for the video. So let's call it a day, and we'll see you next one. Thanks very much for watching.